The focus of this lesson is on solving logarithmic inequalities. And you just want to, as a cautionary measure, make sure that you determine the domain of your logarithms in your inequality, because that will limit what your actual interval is as far as the solution goes. And so to start off as a first step, I would determine the domain of the logarithm of 5x plus 15 in this first example. So 5x plus 15 has to be greater than 0 because you can never be negative or 0, so we have to be greater than. So subtract 15 from both sides. 5x needs to be greater than negative 15. Divide by 5 on both sides. X is greater than or equal to negative 3. So as far as our solution is concerned, we still need to be greater than negative 3 at the end of the day. So then now we can go ahead and actually do our solving steps. So this is log base 10 of 5x plus 15 is less than 2. So when we go to solve this logarithm, we would need to use the base that we're working with, which is 10, and raise it to that log base 10 of 5x plus 15. And then what you do to one side, do to the other. So we took 10 and we're going to raise it to the power of 2. So if log base 10 of 5x plus 15 is less than 2, then clearly 10 raised to log base 10 of 5x plus 15 is less than 10 raised to the second. So it doesn't change your inequality symbol's direction. So you are composing inverses at the end of the day, so you're left with 5x plus 15 by your logarithm property is less than 10 to the second, which is 100. Subtract 15 from both sides. 5x is less than 85. Divide by 5 on both sides. X is less than 17. So you need to both have x is greater than negative 3 and x is less than 17. So if you plot that on a number line to kind of help you visualize, maybe here's negative 3 and then 17's out here somewhere, x is greater than negative 3 would be this interval. X is less than 17 would be this interval, but you need the intersection of those two. They both need to be happening, and so that's from negative 3 non-inclusive to 17 non-inclusive. So your solution set goes from negative 3 to 17 non-inclusive on both ends. We'll go ahead and look at the next example. So we have the natural log of 4x plus 10 is less than or equal to 2. If we consider the domain first, we know that 4x plus 10, what we're taking the log of, needs to be greater than 0. We'll subtract 10 from both sides and we'll get 4x is greater than negative 10. We'll divide by 4 on both sides, which keeps our inequalities direction, which is negative 10 divided by 4. So x is greater than a negative 5 halves, or if you want to put that in decimal form, you can say negative 2.5. So negative 2.5 either way. And then to solve, we need to keep in mind that our base is base e. So we're going to go ahead and take base e on both sides of our inequality, and we're going to raise it to what we had. So we'll raise it to the natural log base e of 4x plus 10, and we'll raise it to 2. And that shouldn't change our inequality symbol's direction. And so when we do that, on the left-hand side, we are composing inverses essentially. So we can use that property and know that we're left with just that 4x plus 10. And then less than or equal to e to the second. We can subtract 10 from both sides when we go to solve for x. So we're left with 4x is less than or equal to e to the second minus 10. Divide by 4 on both sides. So x is less than or equal to e to the second minus 10 all over 4. And it's important to kind of know where this is in relationship to negative 2.5. So this is the exact answer, but go ahead and put this in your calculator and you'll see that it's equivalent to approximately negative 0.65, so negative 65 hundredths. So on a number line, we have negative 2.5 and then negative 65 hundredths is a little bigger, so it'll be to the right. And we need to be greater than negative 2.5, which would be this interval. And we need to be less than or equal to negative 65 hundredths. So if we take both of those into account, the intersection, we'd see the overlap would start at negative 2.5 non-inclusive up to negative 65 hundredths inclusive. And so our solution is negative 2.5 non-inclusive to negative 65 hundredths inclusive, which is just negative 2.5 comma e to the second minus 10 over 4 inclusive. If you want to have it written exact, that's your solution.